Assalamualaikum and hi everyone. We are from Group 3, Subgroup 4 for STB 3022 Environmental Biotechnology. We'll be reviewing our research journal entitled Municipal Solid Waste as a Source of Electric Power Generation in Colombia, a Techno-Economic Evaluation under Different Scenarios.
This research paper mainly describes on how Colombia applied the use of waste-to-energy process and how they can generate economic benefit from it. Waste-to-energy is known as a process that involves the recovery of heat and electricity from waste, especially non-recyclable waste. Waste-to-energy process also plays an important role in the sustainable management of municipal solid waste. Besides, this work also evaluates the techno-economic feasibility of waste-to-energy projects in Colombia using 4 different conversion technologies of incinerator, gasification, anaerobic digestion, and landfill gas. The objectives of the research were to calculate the internal rate return for each type of technology and municipality, to provide comprehensive waste management, and to diversify the energy mix in Colombia. In addition, this research is also vital to promote waste-to-energy projects in Colombia.
Next up is methods. The first method is selection of scenarios. To calculate energy potential of their specific municipal solid waste, one municipality was selected from each group. G1 has municipalities with less than 30,000 inhabitants. UP index showed that 76% of the municipalities were predominantly rural. Meanwhile, G2 has between 30,000 and 100,000 inhabitants. It consists of similar rural or urban populations. G3 has more than 100,000 inhabitants, and the UP index showed that 93.5% of the municipalities were. Subsets of the 3 groups were created whereby subset G1 only includes municipalities with UP more than 1. Subset G2 was defined by the districts with UP between 0.9 to 1.1, and subset G3 focused on municipalities with UP less than 1. Subsets of municipalities that did not have solid waste management plan publicly available were filtered out from the study. Next is energy recovery potential from municipal solid waste. Incineration and gasification were the main thermal conversion technologies evaluated in this study. Production of municipal solid waste in Andes and Pasto were applied except in Gotaya due to insufficient information on the characteristic of the municipal solid waste. Therefore, for incineration, facilities were justified above 100 tons processed per day. Information on the amount, physical composition, and per capita production of solid waste in each scenario was analyzed. Table 1 summarizes the technical conditions that make a technology feasible or unfeasible in each municipality. Meanwhile, energy recovery was calculated using 3 mathematical models, which will be described later on. Equation 1 was used to calculate amount of electricity that can be obtained from incineration. Equation 2 was used to calculate amount of electricity that can be obtained from gasification. Meanwhile, equation 3 was used to calculate electricity production potential which can be obtained from the organic fraction of municipal solid waste. Equation 4 was used to calculate methane emissions from sanitary landfills. Equation 5 was used to calculate the amount of electricity generated by the economic evaluation for each municipality. Capital expenditures and operating and maintenance expenditures were included as economic evaluation. Other benefits considered were electricity sale, income for treatment of received ton of municipal solid waste, and certified emission reduction obtained due to the reduction of greenhouse gas emissions. More benefits calculated were the Law 1715 for the commercialization of electricity from non-conventional renewable energy sources, consisting of income tax deduction, VAT exemption, tariff exemption, and accelerated depreciation of assets. The financial evaluation of each project calculated internal rate of return using a 10% discount rate. The rate was determined based on capital asset pricing model. For the years after 2020, a linear approximation of the previous year's trend was used, which equals 0.7% on average for the different areas in the country. After the pre-feasibility study was completed and internal rate of return was calculated, a decision would be made to continue or abandon the project in each scenario in G1, G2,
3.1 Analysis of selected municipalities. In G1, the inhabitants must be less than 30,000, which only Guayata that provide their information on solid waste management plan. In G2, the inhabitants must be between 30,000 and 100,000, which only Andes that provided the information. In G3, the inhabitants must be more than 100,000, which only Pasto that provided their information about the management plan. 3.2 Estimation of energy recovery potential. Based on figure 1, it can be observed that in year 2020, incineration has saved up to 1.01 megawatt hour per day of electricity in Guayata, compared to other conversion technologies such as landfill gas, anaerobic digestion, and gasification. The same trend can be seen in municipal Andes in figure 2 and Pasto in figure 3, with incineration recovered energy potential up to 6.33 megawatt hour per day and 132.10 megawatt hour per day respectively. Other conversion technologies such as gasification produce less electricity because it used 72.51% of total waste mass during its mechanical treatment and drying, while anaerobic digestion and landfill gas release biogas from 50 to 70% of total waste mass. They also process smaller amount of waste compared to incinerator. 3.3 Economic analysis. Three variables are fixed throughout this entire evaluation. The first one is the price of electricity sold through regulated contracts as $50 per megawatt hour. The second one is the income for treatment of municipal solid waste, such as tipping fee as $10 per ton. And the third one is the income for certified emission reductions obtained through reduced greenhouse gas emission as $0.51 per ton of carbon dioxide.
Next is discussion. In three study case, Guayata, Andes and Pasto, the MSW is considered as a potential renewable energy source in Colombia. The energy recovery of four different conversion technologies, which are incineration, gasification, anaerobic digestion and landfill gas, are evaluated. For each case, suitable conversion technology are selected based on the amount of waste produced, the advantages, the disadvantages, and the feasibility of commercial acquisition of each plant. Pasto and Andes, incineration and gasification are the most convenient technologies. Anaerobic digestion can be used for three municipalities as it can be acquired and exploit a high volume of food waste, which is more than 50% of MSW. Landfill gas is the most adequate option for Pasto and Andes. Of the economic evaluation show a positive economic income from all conversion technologies in municipality of Pasto. Next, Law 1715 influence internal rate of return. Income per ton of waste received significantly determine landfill gas IRR, while the efficiency of anaerobic digestion is defined in the treatment of organic waste. WTE facilities can reduce waste volume in smaller area up to 95% and have a lower environmental impact on soil compared to traditional landfills method. WTE facilities able to generate lower greenhouse gas emission that meet with international standard. An environmental impact assessment can be conducted by following the International Organization for Standardization standards 14040 and 14044 using life cycle assessment. Objective of this assessment is to calculate possible environmental consequences. In accordance with the result, the best WTE alternative would be anaerobic digestion, followed by incineration, gasification, and landfill gas. The investment in WTE facilities can be an alternative to stimulate Colombian economy and attract foreign capital. New WTE processing unit will require manpower, just directly and indirectly creating new jobs to provide services for the operation of the facilities. But construction of new landfills is a difficult job because it requires environmental and technical license, which typically take several years and are not always obtained. Public opposition is one of the main obstacles, as Colombia is that the constitution allows community to decide whether this type of project can be implemented in their environment. The techno-economic evaluation in this work suggests that the cost of WTE plant are not affordable for most Colombian municipalities, and the technology will only be possible in the developed urban area. Colombia has relatively new legal framework of policies and incentive for developing WTE project.
In this article, the techno-economic evaluation suggests that the cost of WTE plants are not affordable for most Colombian municipalities, and such plants will only be feasible in the economically developed urban centers. Therefore, the government support, such as through tax deduction, can promote the use of these WTE technologies. Tax incentives in Law 1715 enable the improvement of rate of return on investment. Besides that, public support is important to encourage the development of these technologies, as well as to motivate the public to demonstrate their moral commitment to the planet. Therefore, campaigns should be held to raise awareness. Last but not least, Colombia must embrace the practices of developed countries to implement these WTE technologies.